Hey y'all, this is going to be the notes, the video for 4.7 notes. Now, if you were at school yesterday, you have already started these and have probably finished the first page and started on the second page of this notes. The reason I'm doing this, just the full notes, is because some people weren't at school yesterday. So this, if you weren't at school yesterday, you'll watch it from right here. If you were at school yesterday and completed some of these, you can fast forward to that problem that you need to see in order to complete these notes, okay? So again, if you were here yesterday, go ahead and fast forward to wherever you need to be. If you weren't here yesterday, let's start at the beginning, okay? You need to box this in. The first thing we're going to do is we are going to change these from standard form to vertex form, or sometimes it's called transformation form. So if you hear me say put this formula in vertex form or transformation form, this is what I'm talking about, this type of form. Alright, to do that you kind of have to remember how to do completing the squares. So what I'm going to do is I'm going to rewrite this problem, x squared plus 4x plus 6. I'm going to rewrite it over here and set it equal to 0. And I'm just going to kind of go through the steps of completing the square with this problem and show you that it's very similar in order to put it in vertex form, okay? The first thing I would do here for completing the square, CTS, completing the square, is I would move over the 6. I would have to move it over by subtracting it. So I'd put a box in its place. Over here the 6 would be negative 6 plus box. I have to add a box on each side, or square on each side, because what I do to one side I have to do to the other. And the reason I have to do that is so I won't change this original problem. Again, when you're putting it in a different form, you're not changing the equation. From here I would divide 4 by 2, which would give me 2. I'd square it, that would give me 4. And if you'll remember what goes in the box, that's this number, 4. Okay? Now think about if we were going backwards. We were going back to here. So pretty much cleaning this up. If I subtract this 4 from this 4, moving it over here, they would cancel, right? Then I'd bring the 6 over and I'd have x squared plus 4x plus 6. So I just want to emphasize that these aren't different. It's just written a different way. But the equations are the same. Nothing's changed about that. Well, here's kind of similar. The difference between this equation and this one is that this is equal to y, this is equal to 0. So instead of moving that 6 over, I'm not going to move it over to y, I'm going to leave it where it's at. This part I'll do the same. 4 divided by 2 is still 2, and 2 squared is still 4. And I'll still add x squared plus 4x plus box. But since I'm not moving the 6 over, it'll stay positive 6. I'm not moving it to the other side of the equal sign. I'm leaving it here. But I don't want to change this equation, right? I don't want to change anything about it, so I'll need a plus box. It's going to be a little different though since it's on the same side. And I'm going to group these together because I'm going to make this perfect square trinomial. So same thing, 4 goes in the box here, but here, think about if we had to add it on both sides so we don't change it, when it's all on the same side, how could I cancel this out to where it'd just be x squared plus 4x plus 6? I'd have to have a plus 4 and a minus 4. So that way these would cancel out and I still have the same equation. I haven't changed it. Okay? Then from completing the square, you would take this, create a binomial. That binomial is going to be x. The number that goes here is half of this, which was 2. And then over here, I just combine these. So 6 plus a negative 4 will give us a plus 2. Now this equation is in vertex form. So again, this that we started with was in standard form. And we just completed the square and changed this to vertex form. The reason this is called vertex form is so you can easily identify your vertex. This one, if we were to try to find the vertex, remember going back to chapter 4:1, you'd have to do negative b over 2a. Then once you get that x coordinate, you have to plug it in to find your y. Not with vertex form. With vertex form, these two numbers are your vertex. The only thing you have to remember, and this is from Transformations, chapter 2, is that x is a joker. Remember? So whatever this is, you do the opposite. So your vertex would be negative 2, not positive 2. And this one is 2. It's not with x, so nothing changes about the sign. That's why it's called vertex form, because you can easily see that that is your vertex. Another thing I want to talk about is the axis of symmetry. Axis of symmetry. Remember, it's the same thing as your x coordinate of your vertex. So our axis of symmetry here is the same as our x coordinate of our vertex. It's negative 2. And then it says direction in which it opens. Pretty much, does it have a min or max? This one does not have a negative out front. Our a is 1 in this case. So it opens up like so. Opens up. And it would have a minimum. Alright, let's try the next one. Actually, I'm going to skip down to number 3 because it's very similar to this one because there's no number out in front. Our a is still 1 in number 3. So let's skip to that one. Alright, the first thing I'm going to do is rewrite it as x squared plus 2x plus box. I'm not moving the 7. I'm just bringing it down so it still say plus 7. We'll have plus box right here. Now what goes in the box? Remember, we have to take 2, divide it by 2. That's going to be 1. 1 squared is 1. So right here we'll have a positive 1, but remember over here we'll have a negative 1. That way they could cancel out, but we'd still have the same equation, x squared plus 2x plus 7. Now you just change this to a binomial. So x, half of 2 is 1 squared. 7 plus a negative 1 is plus 6. This is vertex form. So now my vertex, remember x is a joker, will be negative 1, 6. My axis of symmetry will be x equals negative 1. Direction of opening, direction of opening, I'll just put DO. This one will have a minimum, so it opens up like this. It'll have a minimum. And why? Because a right here is 1. Alright, now let's look at one where it has a number in front. It's not much different. The only difference is our a right here is 1, right here it's 2. Well, if you look at vertex form, you can see that the a is out front. And again, our a here is 2. So we're going to take that and put it out front. So if I take a 2 out from x squared, I'll just have x squared. If I take out 2 from negative 12x, I'll have negative 6x. Now the good thing about this, you won't have to divide 17 by 2. Because the 2 is only being taken out of what's in parentheses. It's only being multiplied by what's in parentheses. And we know that our 17 is not going to be in those parentheses. So we don't have to take a 2 out of 17. We just bring it over and it'll stay plus 17 because we're not moving it to another side. Plus box, don't forget that. Alright, now what goes in the box? You're going to take negative 6, divide it by 2, that's going to be negative 3. Negative 3 squared, we know is positive 9. Don't let your calculator lie to you. So I'm going to put a plus 9. I know right here I'll need a minus 9 to even it out. But I'll also need a 2 right here beside my negative 9. Now where did that come from? Right here. This is my a. So think of your a as like a sandwich, like bread. Okay? You have to have bread on both sides And let me show you why we have to have this 2 right here, okay? You don't need to copy this part down unless you want to. This is just me showing you why this equation is the same as this one, okay? So if I distribute this 2 to each term here, I'll get 2x squared minus 12x plus 18, because 2 times x squared is 2x squared, 2 times this, negative 12x, 2 times this, 18. Then right here I'll have plus 17. From here I'll have minus 18, and if you notice what will happen, the 18s will cancel each other out. So we'll just have 2x squared minus 12x plus 17. Isn't that our original problem? Yes, so I know I've done this correctly. That's why we need that 2 right there. Because if not, it'd just be minus 9, and that would change our entire equation. That's why we need a 2 right here. Okay, so anytime you have an A, if you take a number out, it needs to go right here, just like sandwich. Alright, let's carry on. You're going to leave the 2 outside, just like they did up here. Left the A. This is going to turn into x minus 3 squared, because half of this is negative 3. 17 minus, this would be a minus 18, so 17 minus 18, that's negative 1, and we're done. Alright, now let's identify our vertex. It's going to be 3, negative 1. Alright, axis of symmetry, x equals 3. It's going to open up because this is positive, and we're done. Alright, I want you to try number 4 on your own. It's just like number 2. So if you're working on this, be honest, pause the video, try it on your own, and then unpause it, and I'll work it out with you. But try it on your own. Do it now. Alright, so your A is negative 4 here. That's what you should have taken out. And you only take it out of the first 2 terms. So this would make x squared. This would make positive 6x plus blank. This negative 15 just stays the same, plus blank. And remember, if you have to have an A out front, it needs to be on this end too, like a sandwich. Negative 4 and negative 4 need to be on the inside and outside. Alright, then you take 6 divided by 2, gives me 3, squared gives me 9, so I have a plus 9 and a minus 9. From here I'll leave the negative 4 alone. This changes to x, half of 6 is 3 squared. Alright, this makes a positive 36. 36 minus 15, and the reason I have to multiply these first because order of operations tells us we have to multiply. So make sure you didn't do negative 15 minus 9 and then tag on the negative 4. It's got to be this first. 36 minus 15, that's a positive 21. So this is vertex form. My vertex is negative 3, 21, axis of symmetry, x equals negative 3. This one opens down because A is negative. Means it'll look like this, and it'll have a max. Alright, so that is how you change from standard to vertex form. Flip it over. Alright, these are already in vertex form for us. Yay. So all we have to do is graph. Okay, before we graph, I want you to think about the parent function of this, okay? I know it's been a while, but the parent function of all of these graphs, because all of these are parabolas, is y equals x squared. Now, a lot of y'all didn't remember how to graph this, so anytime you don't know how to graph something, you always make a table. Use Old Reliable. And I'm going to pick these x values. Where did I get them? I just came up with them randomly. But how do you get your y value? You plug this in for x, right? So negative 2 squared, if I plug this in for x, would give me positive 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. This would be 4. And remember, parabolas are symmetric, so these will be the same, these will be the same. Okay, go ahead and graph the parent function. So that's what the parent function should look like. And now let's go back to transformations. If you can remember, if it's with the x, it moves on the x-axis, that's left to right. Remember, x is a joker, so this looks like you'd be moving 5 to the left. You're really moving 5 to the right. And then if it's away from the x, remember, it's moving up or down, and it's positive, so this is moving up 3. So what I want you to do is I want you to put your pencil at the center, 0, 0 of the parent graph. Then I want you to move 5 to the right, 1, 2, 3, 4, 5, and 3 up. 1, 2, 3. Then draw your center. Same thing with the dot right here. Move it 5 to the right, 1, 2, 3, 4, 5, 3 up, 1, 2, 3. Now I'm going to pick this one. 1, 2, 3, 4, 5, 1, 2, 3. Make sure I do that right. I'm one off, sorry. Alright, and now I don't need to move the other 3 because I know it's symmetric, right? If this is the center, and this is up 1 and over 1 from here, I go up 1, back 1. And then same here, I go the same height and then go over 2. And then draw it. And you can see the size of these did not change, just the position of the center. The vertex of this was 5, 3, that's where the center is, 5, 3, right here. So it transformed the parent graph 5 to the right and up 3. So before we graph this, let's talk about what this is going to do to the parent graph. That negative, if you can remember, is going to reflect it across the x-axis. And remember, if you flip something across the x-axis like this, it's just flipping it upside down. Okay, and this 3 is going to move it 3 to the left. Alright, so we're going to graph the parent graph first. That's the same one we started out with, using this same point. So go ahead and redraw that on this graph. 0, 0, 1, 1, 2, 4. Alright, and the vertex of this graph is negative 3. There's no y, so it's negative 3, 0 is the vertex. Go ahead and draw that point, and you can see that's the same thing as moving the center 3 to the left. 1, 2, 3. It's at 3, 0. Now I want to look at this one. If I flip this point across the x-axis, it'll be right here. Again, if I flip it, it'll be right here. It's pretty much multiplying your y value by a negative number. Like at negative 1, it's going to flip this to negative 1, negative 1. It's going to change your y value if we reflect it. So let me show you. Instead of negative 2, 4, it's going to be negative 2, negative 4 if I flip it. Instead of 0, 0, well, that doesn't change. This one changes to 1, negative 1. This just changes to 2, negative 4. It just makes all your y values change signs. So going back to here, if I go instead of to -1, 1, -1, -1, and then I move it 3 to the left, it'll be 1, 2, 3 right there. Alright, I'm going to flip this one, so it'll be instead of at 4, it'll be at -4. Down here, 1, 2, 3, 4. So this is it flipped. Now I'm moving it 3 to the left. 1, 2, 3. And now I can just use this axis of symmetry to find out my other points because it's symmetrical. So here's my axis of symmetry. This one's 1 away, so I'm going to go 1 away in the other direction. This one's 2 away from my axis of symmetry, so I'm going to go 2 away in this direction. And you can see it's upside down, so reflects across the x-axis. It's 3 to the left. Alright, I want you to pause this video, be honest, make sure you pause it, and try number 7 on your own. If you don't need the parent function, you don't have to graph it, but if you need it, go ahead and do it. But pause it, try number 7, then unpause it when you're ready to check your work. Alright, so this one, it is moving at 7 to the left, because x is a joker, 4 down. So I'm going to draw my parent graph first. 1, 2, 3, 4. 1, 2, 3, 4. Alright, now I'm going to move each point 7 to the left and 4 down. So 7 to the left, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Now I'm going to move this one, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. And then this one, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Wait. Oh, 7 to the left, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. There we go. And now I just used my symmetry to draw my other points. Oh man, I made a boo-boo, and you already know what it is. I didn't move it 7 to the left. I'm sorry. Shaking my head. Alright, let me try this again. I'm going to move it 7 to the left this time. Left. 1, 2, 3, 4, 5, 6, 7, and then I'm going to move it 4 down. 1, 2, 3, 4. There we go. Much better. Alright. So you can see it moved the parent graph 7 to the left, 4 down. It did not reflect because there's no negative on the outside. Sorry about this one, guys. Alright, flip it over. Alright, I want you to also try this one on your own. So pause it, try it, then unpause it when you're ready to check this, okay? Alright, so the negative is going to reflect across the x-axis. The 6 is going to move it 6 to the right. 8 is going to move it 8 down. I'm going to graph my parent graph. And again, if you don't need this, you don't have to. And now I'm going to move, first of all, I'm going to draw my vertex, which is at 6, -8. So that's going to be right here. 8. Okay, and if you'll notice that from each center, it goes up 1 over 1. Up 1 over 1. Well, this one would be the same way except backwards. So down 1 over 1 because of the negative. So I'm going to go down 1 over 1, down 1 over 1. I can't really draw my other ones because it's going to run off the graph. So there's your parabola. It's flipped, and the center is at 6, -8. Alright, now you're going to describe the transformation. So pretty much what we've already done. You don't have to write out full sentences. I just want to know what is the parent graph you're transforming and what these do, okay? Let's start with the negative. That's going to reflect, what's the parent graph? Y equals x squared across x-axis. Alright, if you will remember, the 3 changes the slope. It makes it steeper. Okay? So the 3 is a big number, so think about it stretches it, makes it steeper, and it's stretching it up and down, which is vertically. So this is stretches vertically. The 5 moves it 5 units to the right. Remember, x is a joker. And 2 units down because of this down here. So basically the negative reflects. If it's inside with the x, it's moving it left or right. If it's outside, it moves up or down. This changes the slope, so it either stretches or shrinks. And I hope that y'all remember that from chapter 2. I know it's been a while. Alright, we'll do one more together, and I'm guessing you'll probably want to do number 11 together, so we'll do that. And then I will have you do 10 and 12 on your own, then just check your answers. Alright, so 11, the 1/6 is on the outside, so it's going to change it vertically, just like this one, except this is smaller than 3, so it's going to compress or shrink. Either one's fine with me. I'm going to put compress. Compresses, what is the parent graph? Y equals x squared. Vertically. Moves 3, right or left, think about it, right, and 10 down. Alright, I want you to try 10 and 11 on your own. Pause it, try it, and then unpause it for the answer, okay? There's the answer for this one. It's y equals x squared parent graph. Move 9 to the right and 7 down. For this one, it reflects y equals x squared across x-axis. Moves 3 right and 4 down. Alright, that is it for these notes. Now what I want you to do is you're going to go to your workbook, okay? This is your assignment. Oh. Page 57. 57. Go ahead and turn there in your workbook so I can just help you get started. And then this is going to be due on Monday. I'm going to check your notes to see if you did them, and this assignment to see if you did it on Monday when you come back, okay? And this is going to be for a grade in I Now. Alright, so page 57, the first part says write each one in vertex form, okay? Some of these are already in vertex form. You can tell which one because of the grouping, okay? So like this one's already in vertex form because it's grouped, it has the squared. This one's in vertex form, and the last one in vertex form is number 6, so you don't have to worry about doing those. The other ones you'll need to put in vertex form. Identify the vertex, axis of symmetry, and direction of opening. So we're going to go over just one of these so you can get started. And I'll just pick number 3. It's kind of different than what we've been doing because it has no middle term. So you would start by doing x squared plus, let's put 0x instead of no middle term because it's the same thing, plus blank. And again, I put 0 because there's no middle term, so a 0 in front is the same thing as having none. The 6, we're not changing it on the other side of the equal sign. We're just putting -6. So then you'll take your middle term, which is 0, divide it by 2, square it, and you know that's going to be 0. So you'll have a 0 right here, a 0 right here. It's actually -0, but same thing. So in vertex form, this is going to be x squared plus 0. Do I need to put that? Of course not. And then this -6 plus 0 will be -6. So as you can see, this is in vertex form. The only ones that aren't then, this one is, this one is, this one is, because of the no middle terms. So the only ones you'll have to put in vertex form is 7, 8, and 9. And I'm going to do one of those with you because this one is kind of unfair. I'm sorry. I'll do this one with you. This one would just be x squared minus 2x plus blank. Don't change the -5 plus blank. -2 divided by 2 would be -1. Squared would be 1. So I'll add a 1 here, subtract a 1 here. This turns into x minus 1 squared. This turns into -6. Now it's in vertex form. So let's look at vertex, axis of symmetry, direction of opening. The vertex in this one, we discussed this already, is going to be these two numbers. You just remember to change that one. So it's 1, -6. Axis of symmetry is the same thing as your x-coordinate of your vertex. So axis of symmetry would be x equals 1, because these will be the same. Direction of opening, DO, is going to be up. The reason why is because your A is positive. So it's going to be like this, up like a cup. So direction of open will be up. And that's all they want you to do on that, okay? And then this one, graphing each function, of course it'll have to be in vertex form. And if you want to, you can draw the parent graph on these to help you. The only one not in vertex form is number 15. That's the one that you'll have to put in vertex form first. So I'll go over one of these with you. We can just do, I guess, this one, okay? Alright, so, let's make a table on this one. And the reason why I don't want to do transformation is because this 3 is probably throwing you off, messes up the slope. So we'll make a table if it has a number in front, like 13 and 14. Okay? So my x and y table, and then from here you'll see how it changes it. Alright, let's do -2, -1, 0, 1, and 2. If I plug in -2 squared would be +4. Times -3 would be -12. -12 plus 4, -8. Alright, -1 plugged in right here. -1 squared would be 1 times -3 would be 3. -3, excuse me, plus this would be 1. 0 would be 4. And 1's going to give us the same thing, so is 2. Go ahead and graph this on here. got to go a little bit off the graph. That's okay. Oops, messed up on that one. Alright, while you're graphing that one, you don't have to do this, but I'm going to graph the parent function so I can show you something. 1, 2, 3. Here's the parent graph. Okay. I want to show you one thing. This, of course, moves it up 4. And you can see that's what it did. It moved the center of the parent function up 4. The negative, of course, makes it reflect, which it did. But this -3, again, it changes the slope, okay? Look at this first one, how the slope is up 1 over 1, because the parent function, y equals x squared, there's a 1 in front of x. So you go up 1 over 1. Well, this one, the number in front is -3, so all you do is go down 3 over 1. Again, down 3 over 1. That's the slope. Okay? Down 3 over 1. This one's up 1 over 1. This one's down 3 over 1. So think about that when you're graphing this one, when you have to go down 1 over 2. Okay? Again, you don't have to draw the parent graph on all of them. I just think it gives you a good idea of what the transformation's going on. This page plus your notes I'm going to be checking on Monday, okay? And I'm going to post the answers on Google Classroom so that you will be able to check them to make sure you're right. People who weren't here to get the notes from yesterday, I'm leaving a copy on Google Classroom so you can print them out. Same thing with the assignment. If you happen to have lost your notebook or something, your workbook, I'm printing it out or putting a copy so you can print it out. So there will be no excuses. I hope y'all have a fantastic weekend, and I will see y'all on Monday.